Okay, that's a lot of text, but not a lot of depth on any of this stuff, so it should go pretty quickly. A lot of the stuff is just sort of quick things to get people aware. One quick request is that obviously it's too late for this week, and that's fine because I'm just telling you now. But if you can maybe include keywords in your title page slides, kind of moving forward. I will sometimes make edits to those, but it's better than starting from scratch. And you can use mine as an example or other people that have done that. So basically, there's a couple of little research tidbits here that I'll update you guys on, but also just a couple of really neat things that I ran into. I'll send this to Hudson since he's not there, but this is a really neat application of Pix4D using Playbox VR. Has anybody played around with this?
No.
So I'll probably task, oh, Hudson, are you there in the corner frame?
No, he said he'll be here soon. Here it is.
Oh, that's you, Sam. Sorry, I didn't even see you. And there's Hudson. Yeah, so this looks pretty cool. So somebody built, there are two things that came out of this. One is like a hand-painted 3D printed model. So basically they use Pix4D to assemble a scan of this island, and then had an artist hand paint it based on the point cloud, which is super cool. It looks amazing. So it's probably not something that we would try because obviously it's hugely labor intensive and requires a lot of expertise, but neat to see that done. What I think we could maybe try, and I'll probably send this your way, Hudson, is they've got a Playbox VR implementation of this. So I think it would be fun to throw this on the Oculus or the Vive and sort of see what that's all about. I'm borrowing a Oculus from a friend of mine that was using it for gaming. So I've got one, and I may give that a try this week if I get a chance. But Playbox VR, and I've got the link to the article. I ran across this doing something else. I don't know if you guys have seen this, but this is TopoZone. It appears to be a seamless or mostly seamless USGS national map. So I've taken a bunch of these USGS maps and stitched them together, which is kind of a neat, clever idea. So you can just kind of browse around and zoom in and zoom out. Kind of a neat little product. So if you get a chance to play around with that, I would do that. I was impressed. Usually kind of getting a hold of topo maps is kind of annoying. So this is neat to see. We'll talk a little bit more about lab computing resources here in a second. But one of the things that's been on my mind is how to configure and do like large format storage. So we've got 20 terabytes on one of the computers and 10 terabytes on another one of them. That's enough to last us a while, but at some point we may want to start aggregating. So that's on 3 different 10 terabyte drives. I think it might be neat to at some point start thinking about a NAS, which is how a couple of the other outfits on campus do it. Randy Wynn's group has a NAS that they use. Downside of the NAS is that it's fairly expensive. And with the cloud storage capabilities that we all have, it's often easier just to kind of use like a large Google shared drive if the projects don't get too big. So I don't know. Charlie, do you guys use your own dedicated NAS in your research group?
I don't know what that is.
You don't know what that is?
No, network attached storage. Yeah, we just use Google Drive.
Okay. Yeah. So and yeah, NAS would be sort of a dedicated large storage array.
Yeah, we just use Google Drive for all our images and our class files.
Okay. Yeah, I think that's kind of where I decided to take the lab rather than build a NAS, but we'll kind of keep this on the back burner. Basically, we would just need to find sort of a spare computer of almost any stripe, and then we can install this essentially OS. Well, I guess it's built on top of Linux, but the other one, free NAS, is kind of its own OS. Anyway, we'll kind of keep that in mind. No requirements here, but I saw that Planet is offering a new webinar on some of their new base maps. If you have the time free, probably wouldn't hurt to check this out. Usually these are pretty chill hours, so if I can swing it, I will probably do this as well. The OGIS, so OGIS is the Virginia Tech kind of remote sensing GIS consortium. So everybody that's doing that kind of work on campus is sort of loosely affiliated through OGIS, which is sort of managed a little bit by the library these days. They're putting on a kind of a meetup next week, I think, that I may or may not be able to attend via Zoom. But the big thing is that they have a symposium in the spring where they get a couple of people to do kind of talks in the afternoon. And there's a student poster session. So a lot of people that have made posters for whatever. Charlie, you did one of these last year, right?
Right. Yep.
So I think, you know, depending on where you guys are with your research, Hudson, I think that this is definitely a thing that you should do, is prepare a poster for OGIS. This is going to be sort of tentatively scheduled for March 27th. So hopefully most of your stuff is kind of wrapped up by that point. And we can, good way to share this out to the research community. And for everyone else, if you have stuff that's ready, you know, it's good, you know, it's well attended. There were probably, I don't know, 70 people there last year. Molly, you did this last year too, I think, right?
Yeah, and there are cash prizes if you win. So I think it's first, second, and third place for grad students and first, second, and third place for undergrad.
Okay. So yeah, money at stake. Definitely do it. And if you're thinking about, for those of you thinking about academia, it's important to build a track record of sort of participation in different aspects of academia. One of those is conferences. Symposia are sort of a level below that, but they're still valuable and they still sort of show a commitment to the sharing knowledge, which when you want to go on the job market, they will want to see. So it's a good idea to start building up those kinds of opportunity or building up those kinds of things when you can. I ran into this as well. So there's a LAS Tools workshop. So Charlie, are you using LAS Tools at all, or are you over there?
In there. That's actually I'm talking about it in my presentation. So.
What's that?
I'm working. I'm getting there. We need to get the license at my lab. So
okay.
All
right. I think my audio has switched to not my microphone. Hang on a second. Can I switch this? All right, we'll just have to use the laptop audio. That's okay. Anyway, so LAS Tools is kind of a LiDAR processing system that I use a lot, and training people on it is always kind of problematic. So, Charlie, if you're doing it, you may find it worthwhile to kind of go through some of these. You know, they're pretty short, 15 minutes or so. I think you could probably get through the whole thing in a couple of hours.
Yeah, actually, it wasn't that video series, but he did another workshop somewhere else that I used for some of my work. So,
oh, okay. Is that is that one shareable? Is it like on YouTube or anything?
It's also on YouTube. It was like he was in Canada. I think it's pretty much the same kind of.
Okay. If you think of it, can you send the link over to me sometime on Slack?
For sure. Yeah.
Or email?
Will do.
Cool. Thanks. Okay, so this is a bit of a discussion. So computing resources for the lab, I want to kind of check in with everyone and see how things are going. Everybody got their 4 terabyte drive?
Well, we only have 4. We have 5 people already.
Right.
So I can wait till the.
That 5th one should have come in. They haven't dropped it off yet?
I haven't noticed it.
She dropped off this one, Karen did, but I thought it was the 4th one. Unless there was a 4th one somewhere else.
Is there more than that?
There might be another one there.
Might be in the box.
So yeah, we might.
Yeah, there should. I guess I didn't count, but there should have been 4 in the first batch and then 1 for Colleen.
Yeah, I think we have more.
A total of 4 now?
Yeah, this is open. This one open.
Jack, you have yours already, right?
Yeah, I have mine right here.
You guys have 2, you have 1 or?
Yeah, 1.
So we have 6 now. Oh, you don't have 1?
No, this one's like fine.
Okay. Yeah, so we have 5.
All right, good. So remember, I bought these so that everybody can kind of start implementing a strong backup strategy. I'd like to see at least your thesis related work backed up every week. You're all kind of gearing up, so you guys don't have a ton of data yet. Sam, you're kind of starting to get some data.
Yeah.
And Jim, you downloaded a big LiDAR data set, right?
Yeah, that was fun.
So, yeah, now is a good time. Don't wait until you have a lot of data before you start a backup strategy. Get in the habit of it now. And I'll try to check in with you guys, but maybe make it a goal to get your first backup done today. And we can talk strategies for that. I don't really care how you do it. I use a command line interface to do it just through Windows called RoboCopy. If you guys are interested in that, it's a free download. I think it's packaged with something else on Windows. But however you do it, there's a bunch of good GUIs that do it. I think there's good stuff built into the Microsoft OS that does it. So lots of different ways. One big question I had though was data processing. So I've been trying to kind of work with Hudson this week on some of his stuff. And I know that the time has been a little bit split between Riley and Hudson on that machine. And what I was wondering is how's the computing resources in the lab? Are we kind of short to do data processing? Are they all being used to capacity? Do we need another machine?
I think the one by the printer gets used a lot for that stuff, and then this other one doesn't really get used as much. And I know Riley tried to use Pix4D, but their license wasn't signed in or something on that machine, so.
That's still an issue? All right. Let me make a note of that to check in on.
But by all means, if there's funding available for the computer.
By all means, yeah. Yeah, I had always intended to get a third machine, and so it is not a problem at all. What I'm thinking of doing is ordering a laptop. So the laptop that I have that I brought here is pretty good. I think that was like maybe a $3,000 machine. But that's a lot better than an $8,000 desktop, which is what the other ones are. So I think in the scope of things, that might be a better way to go, but I'm open to suggestions.
I just think the other thing was the static IP that we mentioned from Les.
Yeah, let me follow up on that too. I think I sent them an email, but again, sleep deprivation. I've got an idea to do dynamic DNS as well, which we can do. So dynamic DNS would be the computer itself just leases an IP address and reports back to sort of a third party what its IP address is, and then we can use that to log in. So it's kind of a neat compromise. But I'll check in on either way.
Are you referring to like the desktops or the laptops?
What's that?
Are you talking about like the desktops for dynamic DNS? For the
anything theoretically could be using dynamic DNS if we think we're going to need to remote in. The two Windows-based machines, they report in. We do have a resolvable name that works. That's how I remote into the two machines. So there's already a name that exists.
Okay.
But on the Linux side, it doesn't. It's kind of the gist. So we would really only need it on the Linux side.
Yeah, I think with the machine over by the window, like I have the Jupyter server working on there, so I can work on it in the background with other people. But like two people wanted to do a GUI thing, like run ArcGIS at the same time. You have to log in one at a time. I still haven't found a good solution for the Windows Pro doing multiple users.
For Arc Pro?
No, like logging in from the RDP, doing multiple users at the same time.
Oh yeah. Has that been much of an issue? Have we bottlenecked on remote desktop?
I think it's been fine. There's only like a couple times where like maybe I left myself logged in and then I like had to log myself out. But,
Okay. But well, it sounds like we're at least one computer short, so we'll start there and we'll see how it goes. Do you know how many ports the HTC Vive uses, Hudson? USB ports?
It uses the USB and it uses a HDMI.
Just two? Just one USB and one HDMI?
Yes.
And then the lighthouses, what do they plug into?
They sync with each other through infrared, but they also have like the I think USB-C, like if they're not directly plugged into the wall, you can do it. They have like a charge or whatever that you can pull USB-C or whatever.
So they're not plugged into the computer in any way?
No, they're not.
Wow.
There's like a hub that they're connected to. I don't know, but it's like a little
Dongle.
a little dongle which they like plug in.
And then that dongle plugs in and is USB?
Yeah.
Okay. Oh, that's a good design. One of the problems with the Oculus is that it actually eats up one USB for the headset and then one USB for each of the little position sensors. So I've got to use 3. That was a bit of a concern. The laptop only has 2 USB ports and then 2 Thunderbolt ports, so I had to get an external thing, which isn't a big deal, but something I wanted to check in on. Okay, last item here was names for these computers. So it started to get awkward saying like the window machine or the one by the door, which is I think sort of what we settled on. It would be good to name these, and I was thinking naming them according to sort of like Neil related names. But anyway, be thinking of those. We don't have to decide on that today, but be thinking of good, clever names for these
I like Neil Patrick Harris,
machines.
I'm more of a name.
I think that would be a fun one. Okay, so let's see. Is the screen still sharing, by the way?
Yeah.
Okay. So I spent a little bit of time working with Hudson this past week on trying to kind of break through on this LiDAR visualization issue. Hudson will probably provide some of his own updates, but I wanted to talk a little bit about some of the things that I've been doing. We put together a new wiki, which then I kind of later found out that Hudson had already started one, so it's a bit of a redundancy, but we'll merge those back together. And basically, we've got a blog post from 2016, Hudson, is that right?
Yeah.
Detailing the install. Tons of stuff has changed since then, and so we don't have a great resource for the install itself. So it's been a bit of a struggle kind of getting these through. So I just wanted to talk a little bit about what I've been up to. One of the first things I was up to is like, is there a good way for me to log into Linux? So the remote desktop for Windows is super easy to do. I just wasn't aware of what the equivalent was for on the Linux side. Usually if I want to get into a Linux machine, I just SSH in and get a command line and do whatever I need to do. But because some of the work we were doing here was graphical, I really needed access to the desktop. So I did discover that there are 3 different kind of ways to do this. One is to use VNC. Another one is to run Xserver over SSH. I think all of these are pretty reasonable strategies, but you can actually just remote desktop in as well. I had a little bit of trouble getting the install to work. There are a number of different sort of instructions for this online. I think I tried 3 or 4 of them before I hit one that finally got all of the right pieces kind of working together. But I did successfully RDP into Linux. So you can pull a full Ubuntu desktop, which is nice. And then it was kind of most of this is just kind of catch up. Hudson probably knew a lot of this stuff already, but for me, it was kind of going through installing Steam on Linux, installing Steam VR on Linux. It turns out there's no Oculus support on Linux for VR as far as I can tell. That's not definitive, but that seems to be the case. So I can get Steam installed. I can actually get Steam VR installed, but it's not detecting the Oculus. I'm not going to go into the details here, but even with some of that stuff sort of installed, I kept hitting a lot of errors when sort of trying to fire this thing up. So it was a matter of kind of tracking down a number of these errors and trying to resolve them. So these are just kind of notes to myself mostly about how I ended up, what errors I ran into and how I fixed them. I did need to get the Hudson, I updated the driver to the 430 driver. I don't know if I told you that or not on Slack.
Yeah. The reason I hesitated to do that is because it was like experimental, I guess, what it mentioned, at least in the like update side. I don't know. It might be stable, but
I think the 430 one is stable. I think that there's a newer beta than that or whatever, or maybe there's a beta off of the 430. But I think the one that we have is stable. And then I had some notes here about reinstalling Steam. We still didn't solve it, and so I think where we've left it is Hudson is going to install Ubuntu on, or not, well, it's going to be Linux Mint, right, on a little drive. We're going to start from scratch. I think maybe maybe there have been too many attempts and we need to start over. And then the last big thing is that I met with, Hudson and I met with Howard Butler and Brad Chambers. So these are the guys that are behind PDAL. So this is the Point Data Abstraction Library. This is basically another method of working with LiDAR data. So I think that this is kind of the third one of the big three. The first one being working with LiDAR data in ArcGIS, the second one probably using LAS tools, and then the third one using PDAL. We haven't done a lot of work in PDAL in the lab, but this is where I want the lab going. So for those of you that are sort of starting new LiDAR projects, I'd love to see you kind of working through and doing what you need to do using Python and PDAL. We had a fun one here. Apparently they pronounce it poodle, which was news to me. So I don't know. I don't know that we need to adopt that, but their package is called PDAL. They named it intentionally to rhyme with GDAL. I had no idea that there was an alternate pronunciation for GDAL as well, which is Goodle. So that one was weird. I think I'll probably stick to PDAL and GDAL. They seem to be accepted pronunciations anyway. Okay. Howard Butler is responsible for developing not only the point cloud, or sorry, not the point cloud library, PDAL, but also Entwine, or Entwine, I guess is how they say it. So this is a way of sort of carving up. So LiDAR data is huge, and distributing it can be hard. If you've ever had the unfortunate experience of downloading hundreds of gigabytes of LiDAR data, you know what I mean. And so people are always kind of looking for a better way to store the data, which is how we got the LAZ or the LAS format, and also to store it intelligently, in which it's sort of cloud distributable friendly. So in other words, you don't need to download the whole thing natively. You can kind of just look at it through a web browser or interact with it through another web service. And so EPT is a way of storing LiDAR data that's supposed to be sort of cloud friendly and streamable. The other guy, Brad Chambers, that was on the call, he is the guy that implemented my SMRF algorithm into PDAL. He also has some good Jupyter notebooks on using LiDAR data and point cloud data, using PDAL data to process LiDAR data. So Sam, you've been kind of working both with, well, you've been working mostly with imagery derived from the point clouds, but you have access to the point clouds, and you've been using Jupyter. So you might be a good candidate to try some of this stuff out.
Sounds good.
They also let me know about a new file format called COG, so Cloud Optimized GeoTIFF. You guys probably are already aware that GeoTIFFs are what we often store things like. We don't often store imagery in it because we might use like a JPEG 2000 or something. But we would use it to store like DEMs. Sam, the DEMs I think you've been working with have been in TIFF format.
I think they have a world file too. But
Yeah, so a world file is like a little helper file that just partnered with the GeoTIFF. Other options would be, I mean, there are a ton of other formats out there. So the other one you might run into a lot, I mean, there's ArcASCII or the ArcGrid format, which is pretty old at this point. What else do we use? What else do we use to store DTMs? The old AirDOS Imagine format. I don't know if you guys are using that in any of your remote sensing classes. Those are kind of the big ones. The nice thing about COG is that it's a standard GeoTIFF, so you can use it just like you're using anything else. But it's also, the file structure itself is really well organized. So what this means is that you can load only a part of a GeoTIFF that you need. So you could potentially store a very large area as a GeoTIFF. And then as people need to scoop that up into their GIS applications, they could just sort of download it, just that portion that they need on the fly, which is going to make these things a lot more web accessible than they have been. Brad Chambers also worked for Maxar Technologies, and this was just sort of putting this out there, but Maxar is the company that's behind Digital Globe. And then they turned me on to, they had mentioned this. I think once I looked this up, I think that I had seen this, but it had been a while. And I don't think I dug into it any further than I had. And so I'm really glad that they had mentioned this. So they had said that basically the whole of the United States LiDAR catalog is now streamable on Amazon. And so not only is it sort of distributed there, but more importantly, there's a web map based on I/O. You can pull this up and it's going to instantly have all of the LiDAR data that's loaded into it, which should be most of the LiDAR data at this point. It's probably a little bit dated. I don't know when they did the scoop, but we've got 10 trillion points worth of data accessible via the web in almost 1,000 different files. And what's cool about that is that on the lower right-hand side here, you just see all of these names. You basically click on one of those data sets, so you can interactively choose it from the web map, and it will connect you to a Potri served visualization of that. So that means that every LiDAR data set in the United States is one click away from direct visualization and manipulation, because Potri can actually do a lot of different things to the data. So this is pretty exciting. I don't know if you guys have seen like the SRTM tile grabber that people have put together. Anybody seen that one? All right, so so when you're downloading DEM data, going through the national map can be kind of annoying. And so there are a couple of good little web resources that people have put together to kind of aggregate it. All of the data is still served on USGS, but it makes it pretty easy to download. And this takes us a step beyond that, because you can directly visualize the data, not just download it. Okay, so that's it for me. Lots of sort of little things, nothing too big on the research side. Who's up next?
Can I go first if I actually need to leave soon?
Yeah.
Go ahead.
Yeah, so I just, these are my keys, yeah.
Yeah, we all.
We just have a slide open somewhere, or do we have to?
You have to teach.
It's in the Slack. If you put it there.
So, alright. So we want to
What do you take to?
Oh
no.
this is sharing.
It is not.
Put it on where?
Click the Zoom button.
Zoom.
Yep.
And
Go back. No, right. Yeah, there you go. Share.
that was sharing. All right, so I have a couple things to share. It's going to be pretty quick. I have been using Agisoft. Or actually, it's called Metashape now. It's like a new program software that they've developed. It's after PhotoScan, and it's been great in developing these structure for motion point clouds that I need to compare to my LiDAR data sets. But the problem is that obviously, since structure for motion, you can't get below trees, I've been trying to think of ways to try to get some ground points below trees to try to get some better DEMs and whatnot. So I actually have a test flight in 30 minutes where I am going to fly a flight just facing, one flight will have the camera face down, but then I'm going to try to change up the camera angles to see what I can do. So I'm going to try to do a 45-degree camera angle to see if I can get some of these points below these trees and maybe other vegetation and other obstructions. I'm using DJI Flight Planner for that, so it's a little bit different than all the flight planning stuff. So I'm just wondering if anyone has any ideas about that.
Different mission planners.
Yeah, just like, or not, no, just like different, like ways to get a flight with different angles. Yeah, maybe using a different mission planner to have a more streamlined flight. Because I'm just like literally just going to do the same flight twice, basically, and just with different camera angles. But I'm wondering if there's a way to maybe have a flight where you can, like, stop at a certain location and take multiple angles using a DJI Mavic Pro or not. So, just
X4D capture
yeah.
might be your best bet.
Does it? What can you do with that?
You can do like you can have it set so you move, like it'll take a picture every time you move 3 feet this way and 3 feet vertical. You can set that up however you want to.
So you could like take multiple angles at the same
Yeah.
So
location.
you're flying it, and then it'll just
Yeah,
take pictures
as you're
as you-
going. it'll-
Okay, yeah, because we don't have the Pix4D software, but we could.
Yeah, X4D capture the way
Okay.
for what you're doing. But are you really flying at 400 feet?
No, that's just a sample.
Oh, okay.
We're flying at like 150.
I was going to say,
Yeah.
it's like,
Yeah. It's not a very big, like large area, as you can
Yeah.
tell from this. It's just about a kilometer stretch of the street line, which is just like off.
Would 45 be too sharp of an angle?
40, I would go with 90 degrees, 70
75?
degrees, and then maybe 60.
Okay.
Yeah.
What was that angle recommendation there, Jim?
What?
What was your angle recommendation?
90, 70, and then 60. I wouldn't go 45.
Yeah,
30?
45 is likely to be too steep. You're going to get a lot of sky if you do that.
Okay. Yeah, sounds good.
You even try 80, but I mean,
Yeah, so I'll just test out like 80 degrees or something today, and then I'll do some sort of comparison with the old point clouds and see how it goes from there.
And you said your goal, sorry, I was having audio issues again. You said your goal is to try to capture more ground points?
Yeah, start trying to get like below some of these tree canopies that we see in this stretch of stream, and maybe so that I can get better roughness estimates, like, and also more accurate DEMs in this thick vegetated areas. So.
Okay. Yeah, let me know. It'll be interesting to see those numbers. I don't think that I've seen a formal comparison of. Usually they'll use different angles, especially if they're. I mean, they recommend for forested stuff, but they also recommend it for urban areas to try to capture the faces of buildings. But I haven't really seen a formal analysis on this kind of an environment to see what kind of a difference it actually makes. So I'll be interested to hear the results.
Would the flight pattern kind of play a role in that?
It
Yeah,
can,
so
yeah.
I'm flying like perpendicular from the channel, so that we can get try some of those stream banks as well.
That's what I was going to
Yeah. Yeah, exactly. Yeah, correct. Okay, and then my other thing is what we were talking about different, the different methods for dealing with LiDAR or classifying LiDAR or point clouds in general. And I'm probably going to go into the last tools, but I don't know exactly. We don't have a license, so I need to figure that out because it's like 2,000 euros or something. So I'm just wondering, should I actually just go maybe dive deeper into PDAL or something, or just use ArcGIS for now and see how that goes? Not exactly.
So the license that we're using in Neil comes from Valerie Thomas manages it, so she's in forestry. I can't remember who the license is allocated, but we have access to it. I don't know. Usually it's confined to a certain, it's not a university-wide license. It's like a unit license.
Right. Yeah. That's what I saw on the website. Yeah.
But we should have it installed on one of the machines. I think it's on the one by the door.
Okay.
Short run, anybody that's, anybody in that room has access to that and can kind of get you logged in. And so if you want to process some of that data, you should be able to do it there.
Okay.
Longer term than that, we should be able to set you up an account and you can do something like remote desktop in and then process your data that way.
Okay, yeah, I could do that, but yeah, I think I'm working with Cully to get our own license too. So
Great, yeah, it's worth it. $2,000 in the long run, or 2,000 euros in the long run is a pretty good deal. And the maintenance on it is a lot lower than that. I can't remember. It's like a 20 or 30% or something. So
okay,
good,
Yeah.
good to hear that you guys are getting a license for it. It's good. It's a good tool.
for sure. Okay, that's like literally it. So just gonna
Very good.
go flight.
Thanks, Charlie. Good to see you. Good luck with the flight.
Yeah, I'll see you guys later.
Yeah, it's open at what, 20?
That's fine. Yeah. Probably has 6 articles. So we should probably do like hour 5. Yeah. How many do you need? 15?
I can't even.
See you guys.
These are all there. I mean, I don't mean tomorrow. It's
Audio, yeah.
So gotta add keywords to it for next time, but so in my lab report. Thing that's been going on the last 2 weeks, read a few articles, attended another GSA assembly meeting. I joined the Judicial Committee, Internal Affairs Committee. So, and be looking at kind of implementing plans that the executive board wants to happen, and also trying to manipulate the GSA constitution to allow us to make without having it go in front of their university governance. Probably going to be becoming the assembly parliamentarian. So basically the holder of Robert's Rules of Order and the moderating baton here the next week or so. And spearheading a 5-year strategic planning group. And also done. So it's a before picture on the left, and then on the right is what it looks like now. And then I know you wanted me to talk about the GI, the G family of spatial autocorrelation. So it was kind of it was pioneered by Geddes and Ford and invented too. But what it does, it takes a summation of your binary weight matrix right here. It's a simple, a symmetric 1-0 kind of weighting for points that are a distance away from the point out of the ith point of all of your J number of values. So, like, let's say you want to look at the 6th point of like your 10 points, and so that's where that kind of goes, and then that's divided by your summation of all your x values for of all your points. It is scale variant. So what that means is like, so yi equals bxi is going to be the same. Like xi is not going to change between the two. But if you do like this, I guess the scale of it is not going to change, but location variant means it's so yi equals a plus xi. You're going to have different values for xi between the two, or yi. It was hard. What did it say? I was having some trouble understanding it because not the best. Like this kind of math kind of confuses me really easily. I'm powering through it, but it is intended for use with variables with a known origin. So because you need to know Cartesian coordinates for your x values, your points, and then this also just G without a star is used for when J is not equal to I. So you're excluding your point that you're investigating in each time you run it. But GI star or asterisk or whatever is that it you basically include all of your points, including the one you're measuring from, and so it changes up. So it doesn't include that. But there's also some other different, like, so the main statistic, like the main expression right here, that they're the same, but once you include the ith value, it does start to change up, especially around, you get, instead of n-1 is n, you do, I guess, double sum right here. I guess that's what that means. Yeah, and so a lot of just kind of get rid of the -1 or -2 out of all through for the GI star. Yeah. And then next week's plan is I got to take a data analytics test on Tuesday, so I'm gonna be kind of studying for that hardcore this weekend. I found some contact info from Hong Kong for the LiDAR data, but I wasn't entirely sure how to word the email, especially because I wasn't sure if, with everything going on, if it would get forwarded to China, and then it would just kind of put me on some sort of watch list in China. That would not be fun.
Did you email Yang about it or talk to him about it?
I haven't. I don't know.
Start there.
What?
Yeah, start there.
Okay, I can do that. And then my other plan is to read more papers and start creating a large scale annotated bibliography, so I can start working on the literature review and everything like that I have to get done. So.
Okay. The other goal though was to try to get a data set downloaded, any data set that where there's a landslide, and then run the paper that you had reported on, and I can't remember who the lead author was on that one, but to actually implement that and to run it, that's a top priority on any landslide that you can identify, so that you can start to see how these tools pick up on it. Can you go back to, and that's getting a working toy example is kind of a key starting point for everybody, right? The literature is kind of the first stop. You've already done some reading on that. But really trying to kind of dial in on one particular example, and then that's going to give you a base that you can move from. The GI star stuff, next week, I want you to run some data with it and report back on what it's doing. So this is a lot of the math behind it, but probably the math is going to be opaque to people on a presentation like this. So it's really important to kind of give an on-the-ground example of what it's doing. And that'll kind of help you kind of see what it's doing as well. So focusing in too much on the math is less important than what does it do on the ground.
Okay. Sounds good. And then these are my references.
So GI as opposed to GI star, did Getty's and Ord do that as well?
Yeah. So GI. They started off with both of them, but in the second article in '95, so it came out in '92, and then in '95 they did kind of not a rework per se, but they explained it more, and I guess a little bit more calculations. But looking through the two papers, there isn't a difference in the calculation itself. I think it's like the probability calculations that they've done when it comes to the individual things, but they definitely explain it more in the '95 article.
Okay. And how familiar are you with autocorrelation in general?
Not.
Okay. Do some background reading on autocorrelation, because I think that's going to help you kind of get a handle on what's going on.
Sounds good. All right.
This is likely to be an important metric for your thesis, so it's one of those things you're going to have to spend some time on to really get to the bottom of.
Yeah. Yeah.
We're going next.
I get somebody. Yeah.
Do you see the screen or?
No, not yet. Sorry, I had to pack up and move. My in-laws came home.
That's always fun. Cool. So I'll try to keep some from redundancy based off of like overlapping stuff with Dr. Pingle. But yeah, so I was just kind of working with that poetry format, kind of just interaction amongst the point cloud. So there's some volumetric calculation implementations that you can do in the point cloud. So these were GIFs before. I don't know what happened to them because GIFs are awesome. But yeah, so basically it was just creating bounding boxes to calculate volume, whether that's like the light post or the tree volume. Obviously, there's like some areas where is not the tree and is not the light post that gets calculated with it. But you can do some like clipping and fine tuning of it. And then you can ultimately extract certain portions of it. So if, say, I wanted to take out just the telephone pole or whatever that is, I could do that and then do my solo calculations within that. But yeah, so what's cool is that similar to what we were talking about with the formatting that we mentioned with PDAL and all that, that it is a web-centered format, so everything gets exported into JSON, which can easily be translated, as well as very user-readable and useful for indexing and all that kind of stuff.
So I only played around with this a little bit when I was looking at the USGS stuff. When you're exporting to JSON, is there a way to export all of the points or to get all of the points back out? Maybe I didn't spend more than a couple minutes on it, but
what do you mean by all the points? All the points that you've like selected, or?
Yeah.
So I mean, you can do the whole selection, and then you can do like the else selection, or what's the anti-selection? Everything that's not currently selected, and you can clip out different portions of it. And yeah, you can export it to JSON, or there's like a DXF format. I can't exactly remember what that is. But
you can get, and okay, so when I was doing it, it might have just been what I had selected at the time. But like if you click on like it was trying to export like annotations to me or measurements as opposed to the actual point cloud itself. Yeah.
I think it's based off what you have selected in that
window by objects.
Yeah, if you see that like objects window at the bottom right picture, I think it's whatever you have selected is what it will be exporting.
Got it. Okay.
Yeah.
Yeah, this is one of those things that probably anybody working with LiDAR in the group should spend 20 minutes, including myself, to spend a little bit more time, because really this is the way that this stuff is going to get increasingly delivered. LiDAR data is huge. There's a steep learning curve, and if you can kind of package LiDAR in a way that everybody doesn't need to download Cloud Compare or ArcGIS to do some basic work with, that's kind of the goal, and that's why all this stuff is exported out into a Poetry format. So it's worth our while to get reasonably good at it. And Hudson, you're kind of our point person on that. We'll come to you with questions.
Yeah, so the whole system itself is very slippy. It's very quick in how it renders and everything like that. And if you have a decent machine. Yeah. Anyways, yeah, so I'll keep it short based off of, we had the conversation with Howard Butler and Brad Chambers, very smart guys, running circles around my brain. But yeah, it was cool to see how all that tied together, the kind of the genesis of PDAL and all that kind of stuff, and how they've kind of decided to keep it open source, as well as like an avenue for making sure that all the formatting is easily accessible by developers. Whereas, I mean, I made note of one thing he said, was that he was kind of mentioning how Poetry and other systems have kind of like jumped the wall of sometimes of like data continuity and what's the word, transparency. So where like they're wanting to have their whole entire indexing and everything out there for people to use and utilize to their own benefit or whatever application area they're doing. But yeah, they were giving great heading in regards to platforms and resources in order to hit and look at basically all that stuff that Dr. Ping mentioned. Yeah, so I'll definitely be looking more into Entwine as well. So they seem to all be kind of interconnected. So I did a lot of
one quick comment on that. I just really enjoyed, the more you get a chance to put a face on this kind of work, I think it's really exciting, and you get to see how much of the discipline is being driven forward by individuals, which to me is pretty exciting. Like there's just like a handful of people that are kind of driving the open source LiDAR side, and these are two of them, and there's probably 8 other people that are doing it. It's a small group, and it's pretty exciting to get a chance to actually talk to them. So I really enjoyed it. Thanks for setting that up, Hudson. It was a good time.
Yeah, so it's good stuff. I like friended them on like LinkedIn and all that kind of stuff, connected with them, and maybe hoping to rub shoulders with Brad Chambers, because I hope to put like a application in to work at Maxar. That would be
Yeah. Yeah.
So having that kind of little connection and rubbing shoulders would be good for that.
It looked to me, I mean, and I haven't looked into the details of this. I'd love to ask these guys a little bit more about the history, but it seems to me that essentially these kinds of projects are being sort of funded by the government, DoD side, and they had mentioned the Army Corps of Engineers. I think the federal government is just really interested in trying to keep LiDAR open, and these guys are the guys that are making it happen.
All right. Cool steal. All right. Yeah, so I did a lot of research, reading a lot of articles this past week in regards to classification filtering algorithms, in regards to structure motion, photogrammetry, and LiDAR-based applications. Came across this one study that had kind of them almost like ranked in a way based off of, as you can see in the figure, where they set the critical range value to each algorithm to kind of match so that there's like a level playing field between them, as well as using a data set that is continuous between all of them. So a lot of the classifications or algorithms determined are sometimes used on niche data sets or niche study areas where they would perform really well. I think I read one that was like very good for terraced areas, kind of thing, but is not quite good for, I don't know, this general ISPRS regulated data set that they have. So yeah, they all make use of different algorithms. A word that I came across a lot was anisotropy, which is a measurement of directions. It's basically based off of molecules, but in this case, it would be directions of the points or the kind of orientation of them, which I was thoroughly confused by. But yeah, what was also cool is that shout out to Dr. Bingle is still towards the top of the list there.
Second place. We need somebody to revisit it. The simple morphological filter was always intended to give way to the next iteration, right? That was supposed to be version 1.
Yeah. So but this was a 2019 study, and it's 7 years later, it's still going strong. And then there's all these different cloth filtering algorithms and things that kind of fill specific instances, like I was saying. So
the cloth filtering stuff is kind of the new hotness. There's a new the one that's in Cloud Compare is a ground filtering. Can you send this to Jim as well? Jim, when you're kind of working on planning out your thesis, I think it's going to essentially follow a similar model. I mean, you're not testing this exactly, but it'll give you a good chance to sort of see what a good sort of comprehensive study is all about.
Yeah. And then one of them is Axelson, which is 1999, which is a comparatively, relatively more simple algorithm in regards to all the different kind of metrics they're throwing at filtering nowadays, in which I think it was Bayesian based, just raw calculations to filter out the ground that way.
It actually operates on a tin, which is interesting. Tin based versus DEM based algorithms are kind of a interesting touch point. I personally loathe tins, but so my algorithm is DEM based, but Axelson is tin based. It's a progressive tin densification algorithm, and I think the LAS tools version uses a variant of Axelson's.
So basically, a lot of these names are different articles that I've read in the past week. And then in regards to that, on the photogrammetry side, there is a paper by Becker, which is kind of the photogrammetry all for point classification. So that's implemented in Pix4D, which I can't spell right. But yeah, so the whole idea of X4D's classification is that they do it themselves, but then there's opportunities for you to go back in and manipulate it, change it, get rid of erroneous points, that kind of stuff. I think I linked a video to this picture or something like that. It's like one of their technical specialists going through it. But yeah, it's basically that you go into the array cloud, which is the overlaying of the images in the 3D point cloud after it's already been created, the densified point cloud, and then you're able to kind of enter an editing mode where you can draw polygons or around the points that you want to look at, and but yeah, so with that, that video I was trying to show is that if you're drawing a polygon around anything, it's going to catch the background points as well, and their fix for doing that is basically just clipping it to the area that you want to do the editing, which is a decent workaround, but it's also just kind of like a, I don't know, jumping through hoops type thing. But yeah, in the Array Cloud, you can clip the points that you want and then do the correction and reclassification, and anything you want, you can delete it, all that kind of stuff. So yeah.
Did you walk through that process yourself?
I did not, but I understood the process. I've done it before, so.
Okay. Yeah, put together a thing where you kind of go through and do it. I think having a, yeah, I'd like to see the process kind of start to finish. If you can put together like a little video.
Yeah, I mean it's similar to kind of most interfaces that would work with it. I imagine like any other cloud or software, where it's just kind of this interface over the desktop where you have the three-dimensional data model and you're kind of drawing this artificial polygon around it.
But you can do reclassification this way. You can edit classification.
Yeah. So the classification. I mean, most of these photogrammetry ones, they just classify the ground. So it's like classified ground points, and then at least in the video that I was watching or that I was looking up in the software, was that there was a classification of like buildings or vegetation or anything, but it was if you wanted to, if you saw something or points that needed to be classified as ground, you could do so, or you could just delete them, or you could put them into like you could set a new group to drop them in that classification.
Okay. Yeah, just put together like a 10-minute tutorial video on it. Okay.
Okay. And yeah, and then another one or another software kind of in the same realm was this called Primitive IO. So they model themselves as an IDE, which in most coding areas is an interactive development environment, but they call it an immersive development environment, where you can wear a headset and where it allows you to visually see code and interactions between code. I don't know exactly like what the, I don't want to say benefit of this is.
Utility.
Yeah. But I don't know how it kind of like structures it, or if you have to pre-configure it in order to get what you want out of it. But it might be interesting to see like Octree structure formats of a point cloud, kind of how they're being hierarchically structured. I don't know if that's like something that this would do, but yeah, it was definitely interesting to see. I don't know. I could see it being interesting in a lot of different workflows, but I wasn't quite sure it would provide tangibly without actually having to get into the nuts and bolts of it.
So probably a dead end as far as we're concerned. Nothing.
Yeah, I mean, it looks fun, but yeah, I don't know like what specific application areas or what people have actually used it for in their own kind of development sphere. So I'll probably have more research on that.
Yeah, we could probably shelve it. That's probably good enough. Thanks for looking into it.
Cool. And then another one, VR Mesh is kind of a software for feature extraction, point clouds, and then ultimately reclassification as well. A lot of different tools. This is used by the architecture, engineering, and construction industry. Mostly that's what their like target market is. But it's like a streamlined workflow in order to do that. So it's similar to, I guess, most, like I was talking about with the Pix4D. So you've got this kind of interface from which you can manipulate and rotate on cloud and then draw bounding boxes. And that top picture is kind of, they drew a bounding box relative to where they decided the cutoff for the roof was of the building, and then I guess reclassified it to make that segmentation or that grouping calling it the roof. But yeah, there's also wall classification based off of that, and I think it's open source. I've got it downloaded, but I haven't played with it myself in any format, so I'll probably do that. So.
Cool.
And then goals, write. As always, writing is not fun, but needs to get done. And also getting into more interest or research in regards to the stuff that Howard Butler mentioned with Entwine, getting into in regards to that and the nuts and bolts and seeing how it can work with VR stuff. And like I mentioned, VR mesh implementation, and then as well as forming modalities of interaction between the point cloud that I have currently in Unity, whether that's like, I don't know, as simple as adding buttons for filtering. I think that would be beneficial and definitely something interesting to see. Just like have a button that automatically filters the point cloud and then does it on the fly right there in the scene as you're in VR. So yeah, that's what I'm looking for going towards this.
Very good. All right. Thanks, Hazen.
All right. Who's up next?
Don't you delete the link?
Well, for your yeah.
Do you want to go then?
I have the 6 articles to present, so I'd rather get, if you guys have short stuff, that's fine.
Okay, mine's not super long.
We're down there.
Okay, can you all see this?
I see Slack.
Okay. How about now?
Yep.
Okay. So for our lab, it's the first time we used SketchUp, so I'm pretty proud of it. I like how it turned out.
Yeah. Did you paint it?
Yeah, Jim brought in some like enamel bottle paint. So the letters are like 2 millimeters off the rest of the surface. So it's kind of nice textured. But I think here in the the sign that they put up for us, I might also put our names on it. It does kind of struggle, at least with the font I used in smaller sizes, because the certain parts of the letters are just so narrow that it just doesn't print them. So, but yeah, it turned out nice.
Yeah, that looks nice.
It definitely looks better from far away. But so I talked to Dr. Shah about my thesis committee. He was surprised that I was really thinking about that already, and also that the kind of tentative plan now is to go do monthly surveys of the beach. But he said he'd be happy to be on the committee and everything, so it's good. I also got an email back from Dr. Carstensen. He said he would be interested in doing my committee as well. He also recommended that there use LiDAR surveys instead of flying to get our own structure for motion data, but I kind of want to fly anyways. So that's kind of the new. Lots of people have used LiDAR before, but there's also not this monthly time scale of LiDAR data available.
Yeah, I would, as a consideration, I would probably try to look for a spot that has, one or ideally multiple LiDAR surveys, but that doesn't mean you shouldn't fly. That just gives you another thing to compare to.
Yeah. So yeah, so it's good. So now I've kind of got plenty of people that I've talked to so far.
Great.
And so you asked me to report on the Geiger mode LiDAR. So it uses this Geiger mode avalanche photodiode sensors, and the main significant thing seems like it can detect single photons of light, which is pretty oops. And so it was originally developed for the military, I think like 30 years ago or so, but it's kind of been recently started to have civilian applications. It seems like there's only a couple companies who are really using it or making sensors for it, but the benefits are that it's lighter, smaller, can fly at higher altitudes, requires less power. Because you're at higher altitudes, you can also get a wider swath and also go faster. And this is all with the same point density as traditional LiDAR techniques. So yeah, it definitely has some significant advantages there. And there's also, it will get multiple looking angles, so shadows and stuff will be less of an issue with it. So it seems like it hasn't had a ton of civilian use yet.
What are the drawbacks of I feel like this should be something that's primarily used.
Yeah.
Why is it
I think it's expensive.
It's expensive. That's exactly right. Yeah.
Yeah.
gotcha?
And it was, most of the information came from the companies that are actually selling you the sensors, so they're kind of like how great it is.
It's perfect.
Yeah. So yeah, but yeah, it is expensive. And then so this week was kind of a slow week. I missed a few days. So I'm working on land cover data for Anne Maria. We're looking at like how much green space there is for in coastal communities for recreation and stuff like that. How that affects place attachment. So then also just did some reading for thesis stuff. It's Georgia Hate Week this week. Yeah, we play Georgia at noon tomorrow.
We get crushed.
Yeah, we're probably gonna lose. Well, yeah, we're at Georgia too. It'll be a rough game. I probably won't watch it honestly. I finished all my goals from not last week, but like our last meeting. So that was nice.
Yeah.
My goals for this coming week, I want to talk to Dr. Crawford on my thesis and also really get going on the Part 107 stuff. Pick a date. Thinking I might not use the pool fund because that would take a while.
Right. You could probably use the pool fund to fund your travel to the coast.
Yeah, I was thinking that would be a good application. But I'd like to be able to get the Part 107 done by at least next semester.
Yeah.
Like the beginning of next semester. Then I want to keep going, chugging away on that place attachment stuff. I also need to get in the habit of writing as I go, just so I don't miss anything. And also, that Coastal Hazards project I've been working on is coming up. I need to keep going on that so I don't procrastinate too much. That's all.
Yeah, that's good, Jack. Thanks. One of the things that I would say is that the writing part every day is really important. The more you can kind of, try to add. My goal is always to try to add like 1 or 2 slides to my weekly lab report every day, and that kind of helps me pace out the work and then get it to a point where it's not overwhelming at the end of the week, and I'm not kind of struggling on Thursday to kind of try to cram everything in. It's just one of those things that just helps a lot. I don't know. I'm not going to ask around, but I don't know how many of you try to space it out. But I would encourage you to try to do that next week. Try to produce 1 or 2 slides that you can talk about at the lab meeting. You may not hit that every day, but if you can hit that most days, you'll surprise yourself at how easy it was and how much you've accomplished in a week.
Okay. Can we go, Sam? Yeah.
Jack, did you run across any images of the Geiger mode LiDAR to kind of demonstrate what its capabilities are?
Most of them, but like DEMs or anything like that from
Or visualizations of the point cloud?
there were also I found a lot of diagrams on like how the sensor works itself. If you want, I can add those like next week or something. But
Yeah, I mean, see if you can find ideally, I'd love to see like a sample of Geiger mode LiDAR data.
or like a comparison between that.
Yeah, either a comparison would be good. Somebody else's visualization of the point cloud. In a perfect world, I'd love to see like a sample Geiger mode LiDAR data set you could actually download and look at.
Okay. Okay, I'll put that in my to-do list.
You may be, there's a lot of money to image the coast, and you may find that somebody has actually done a Geiger mode LiDAR survey of the coast somewhere.
Okay.
Which would make an interesting comparison because you could really look at an ultra high resolution LiDAR data set, which is much cleaner than a photogrammetric one, and at least give you some idea of maybe what the photogrammetric scan is going to look like when you get there.
Okay, sounds good.
All right, I'll start. Overview. I had kind of a staycation for fall break, and I got some of my tasks done, but the last 2 weeks haven't been as productive as I would like them to be, so there's still some unfinished tasks I need to hit on. Fall break, my better half, my girlfriend came out to visit me from Chicago. Stayed around Blacksburg. We hiked to McAfee Knob, which was it was 5 hours, and they said it was medium difficulty for Virginians. For people, for normal people, but I said for 2 kids from the flat Chicagoland suburbs, don't hike, it was pretty hard. What? It's it was cool. And then when we got there, it was all cloudy, so it was just, you didn't really get the scale of how high you were. So it was maybe the most rewarding hike in the world, but it was cool. It was nice to spend some time together. So last week or 2 weeks ago, I talked about the distribution of Tornado Pass I was working on. And I was messing around with it a little bit more last week. So this is all GeoPandas. I imported the data sets. For the NOAA, it was 1960 to 2017 tornado path or tornadoes data set, and then within there you can get the path length. And I was presenting up to here, where I did a histogram, 50 bins. You can see how there's this steep drop off. So a lot of the tornadoes are between 0 and 50 miles. There was the max was 234. You can see up here, miles for a tornado, which is really high. So what I did was I started breaking down and calculating the 95th percentile, which was 15 miles. And I queried that, and you can still see this large kind of drop off, this log or exponential decay. So in pandas, you can set to log scale. So I did log scale, and it kind of looks like a linear step down. And I kept going further, and I queried the 75th percentile and down, and got this histogram, which looked pretty wonky. And I forgot to put in the data, but the breakdown of it was the 75th percentile was 3.1 miles or thereabout. And the histogram in GeoPandas finds does I don't know how it calculates the bins, but it kind of does a break, a good fit that it finds. So what I did was I recomputed it, and I did a really high number, which was 100 bins. And what I noticed was you're seeing these spikes of tornado lengths at nice intervals. And I was looking at it, my hypothesis right now is that it's the forecasters, when they're putting it into the system, they're putting it at nice values. So 2 miles, 1.5 miles, a mile, half a mile. quarter of a mile. I think that's what's maybe throwing it off. And then I did a log scale, and you can really see how it's skewed, and that these kind of values that I think it's like a human error I came down to. Like that's the name for this, is a human classification error. They're putting it in wrong. So just kind of an interesting thing Dr. Ping wanted me to show you all.
Yeah, I wanted him to talk about it because it's a good find in terms of digging into the data and finding, so I usually refer to these as artifacts, something that looks like it's a signature in the data, but it's actually just a signature of how, either your algorithm worked or how, in this case, how a human wrote down the value. So this is pretty common in data analysis, and it's a good thing to keep an eye out for.
Yeah, it's pretty interesting. Pandas is my favorite, so I like kind of messing around with that like that. Jump back to my PowerPoint. Okay, so one of the things was the Keenfield and DeBurr's paper that was 2 meteorologists looking at tornado path lengths and tornado path damage in the spectral signature of them. And I presented this in theory, remember from yesterday, those who were in it. One of my 2 goals was to figure out how the tassel cap was calculated in the forest. I forgot the name of it. Forest disturbance index. The tassel cap is a type of, it's kind of like this principal component analysis type of calculation. It's a weighted sum of different Landsat bands, and then the output is brightness, greenness, wetness, and from there you can kind of like do some interesting analysis of your vegetation. But the problem is it's spectral information. So for our case, it wouldn't be able to work on an RGB drone. Maybe if we had a spectral sensor, we could try and port it over, but it's more for like Landsat data. It's only I've only seen it used with Landsat. And then I found a paper that, or a blog post that showed the weighted sum of how it's calculated.
And that's what you got here down below, right?
Yeah, at the bottom. I would have to do a little bit more digging into how it's exactly calculated, this type of transformation. But I know that AirDAS can do that calculation if we were to go that route. But it's kind of more of a special thing. And then the DI, so Forest Disturbance Index, is derived from tassel cap transformation. It indicates the amount of diminished spectral returns from damage of forestry in particular. So what the papers that I've used that like to favor it because it's a good way of showing recovery. So the higher the DI value, the more damage or destruction of a forest there is. And then in that paper, the Keenfield and DeBurr's paper, they use DI to show how the forest recovered from a tornado that passed through. And that's, since it's derived from tassel cap, it's based off spectral imagery. So it wouldn't be possible with an RGB sensor.
So one of the ideas that you could do, so I think the idea would be to take something like this, because forest disturbance index sounds exactly like what we would want to do with the tornado paths, right? Like ideally you could calculate something like that. So the question is, how could these kinds of metrics be adapted to RGB, or potentially if we've got sort of an IR signature we could capture from a different camera.
Yeah.
So one of the interesting things that you could do would be to essentially run this on a Landsat image and kind of get those results. And you could do the same thing. You could basically run a correlation between those and like RGB values, and you could see if there's like an approximation, right? So think about it like a regression. So regression is taking a variable that you have and trying to predict or essentially weight a variable that you want to model. And so essentially you could do that same thing, and it would be an approximation, but it might be a useful approximation. We'll talk about that at the individual meeting, but that would be kind of the idea.
Yeah, I think I saw somewhere that someone did a transformation where they got never mind. Well, the greenness value might be something that would line up.
Right.
Yeah. And then Not too significant, but I forked the NeilPy repository, which is one of Dr. Pingle's packages that store is the Neil related functions, and I'll be doing some development with endpoint functions that I create in it. One of the things I wanted to mention was I'm using Git to manage the package, which Git is pretty hard. So I cheat and I use GitHub as a GUI. So if you don't have any experience with Git, it's a good way of managing code and handling the changes and deviations. So if you have two people working on a project, they're going to be two different, I forget what it's called, but breaks from the main code. So it gets a good way of merging together. Linus, the guy who maintains Linux, made it. So it's pretty like hard to learn. So if anyone who knows Git has a good tutorial that we can throw on the wiki, I think that would be pretty cool. But I like the GitHub GUI. It's a good way to cheat.
Yeah, actually, we should put our heads together on that, Sam. I usually use the command line, but I only know the few commands that I need to know to do the job, and then anything else I've got to look up if anything weird happens.
Yeah, no, the command line, if you think linearly like that and you can remember everything, I think it's perfect. But it's kind of hard to follow sometimes. So it's nice with here because you can see with the NeilPy package, it shows the files that have changed from your branch. And then you can change your branches, you can create new branches. You can fetch your origin and then push from there too. And then in the bottom left, you have your summary. And they just updated it so that it autofills like a Git kind of format summary. So I know there's the maintainers of SciPy, they have their own way of doing it where you write what you're doing. So say if I added a file, I'd write add in capital letters and colon, and then what I did. This is kind of, I guess, more of the Git version of it. So just I pushed a file that notebook file that I just presented to my web site, and that it autofilled it. It just said created IPython notebook.
Cool.
And that's what was in my commit message.
So is this GitHub desktop or is this something else?
GitHub desktop, yeah.
Sweet. Yeah, I'll check it out.
Yeah, and then on Linux, there's I forgot the name of it. It's like an octopus is their logo. But there's a open source free version that you can push code like that, which is pretty useful. But yeah,
Is it ink?
I don't know,
Code ink or something like that.
maybe. Kind of looks like this, but and then I since I had that Drive file stream set up, I use that as kind of my anchor. I put all my code in there, and then I push from GitHub, so I can be coding on my Linux or my Jupyter notebook, and then the changes will sync with the Google Drive file stream, and I'll push them from my desktop. So
Very nice.
And then for next week, I have a couple goals. I'm gonna kind of reset myself because I kind of took the weekend or last weekend off and had some time off, so I'm gonna get back on the horse and get some work done this weekend, and then work on a couple of bits and odd ends that I have on my to-do list, and probably do some more reading. And then there's nothing significant schedule-wise coming up, so that's all I got.
All right, sounds great. Thanks, Sam.
15 minutes to go through 6 articles.
Do 2 parts.
I have to. Do you see the updates?
Yep.
Okay, so I have my 6 articles that I haven't presented yet. So this was about a software package for R, so you can actually compute them in R instead of ArcGIS or the other one that's free that's not necessarily as free. The aim is to give a high quality graphical results. So the picture that I included in here is an isochrone. So basically from the starting point, it's giving out how each one is each line is a certain measurement of time it takes to get out to that place for walking, hours. The only thing is that it mainly relies on slope, so there's a whole lot of other factors that should be taken into consideration when creating, such as terrain and geomorphology, but it's helpful as it may provide another way to create a least cost path aside from ArcGIS and ArcPro and all that, which later on it'll become apparent why it might be a good idea to look into.
Colleen, one quick question. Are you in Yang's R class?
Not yet.
Okay.
I'm planning on taking it like next semester or next year,
Okay.
whenever it's offered. This was another article that I was told to read. It was actually done by Dr. Baird, who works here as well. And so they were basically looking at where the Maasai, who are they were pastoralists, but because of modern day stuff, they're gonna have to. A lot of them are trying to figure out where to settle, and so the study looked at where they were settling based off of like the needs of the livestock, environmental constraints, and infrastructure, but they didn't actually interview anybody. So all the data that was used was from remotely sensed images, and so while it doesn't have that qualitative data of why they chose to settle there from like the households, it is helpful in giving a background on how to conduct studies where you may not be able to interview people, which is what I'm probably gonna have to do. This article was looking at what factors influence relationships between Roman infrastructure and settlements in the Upper Rhine Valley, so like Alsace-Lorraine, that area. And so they found that the roads were in fairly efficient locations in the high terrace section, which makes sense because it's out of the floodplain. And it also looked at like types of soil and slope and land cover. And it's useful because it used at least cost path analysis with multiple different factors instead of just slope. This was a paper written by Dr. Pingle. It looked at the usefulness of least cost path analysis and mathematical and graphic modeling and ground truthing. So it helps me assess the merits of LCP when only slope is included. But I do want to focus on more than just slope because I also have like the whole spatial scale and like the whole terrain and all that I want to look at as well. This paper, I had to like stop reading it for a second because like it just blew my mind. There were locations of other Hittite settlements based off of a series of tablets that have names on them. So they use this gravity model, which is actually also the equation we use for calculating the gravity of pretty much everything in physics. So I had to stop for a second because it just was like, wait, what? But basically, the more times a name appeared on a tablet in relationship to another, they're like, all right, this is getting closer to this place. And so, I mean, I thought it was really cool, but it's also useful in that it can help me figure out where other settlements could be based on location if I happen to run across something that has like a list of different known sites and unknown sites. And then the last one, yes, this isn't really a geography paper, but I was interested to see if there was interactions between Incans and Amazonians, and the answer is yes. So there's this play that there was some debate as to whether or not it was actually written by Incans, but considering the fact that the Spanish banned it at one point, most likely it was. And it's basically a love story where this dude is like, I love this other woman, and so then there was a rebellion, and then they made up. But the paper talked about how there was interactions between the Amazonians and the Incans, as it was not uncommon for Amazonian women to marry Incan men in Cusco. Traditionally, it was women to men because the women would have to submit, but like, so it wasn't as common the other way around. I tried a least cost path analysis. I looked up on ArcPro how to do it online, and I couldn't quite get it. I tried. This is
That's okay. As you got an attempt, I'm really glad to see that.
yeah. It says it did it, but it really didn't. So
Yeah.
I don't know where all these colors came from, but I did zoom to layer, and they're not there. So I'm gonna have to. If you can see, that's my third attempt at trying to so I'm gonna probably try to look up some sort of module online to figure it out, like some sort of video tutorial.
Awesome.
Yeah, I tried.
No, I'm glad. I'm super glad that you tried. That's big progress right there. Cool. All right, well done. The play one is really interesting. I want to take a look at that one. And I'm glad that you. So when you say you had to pause on the Tobler paper, pause out of because you were enjoying it, or pause because you were getting a headache?
Pause because it's just one of those things that completely caught me off guard. That I was like, yeah, it makes sense, but at the same time, I was like, wait, what? Because it is the gravitational equation, like how you can calculate gravity between two masses. It's the same concept.
Yeah. So the gravity model in geography has a pretty long tradition. Tobler has another really interesting paper where he actually analyzes how well the gravity model predicted the growth between Dallas and Fort Worth, and he's got a couple of really good like satellite photos that do it. So yeah, you'll probably find the gravity model popping up here and there in a lot of your geographical work.
It's a good thing I started as a physics major.
Yeah. All right.
It just blew my mind that this physics concept was used for geography, for interaction between sites.
Yeah, it's a really powerful model, and that's why I enjoy Tobler so much, is that he kind of brings on a lot of these ideas that are sort of, metaphorical extensions, and they end up working beautifully. Okay, let's see, that covers everybody, right? I wanted to check to make sure that I've got my schedule correct for the afternoon, because I've had it incorrect a couple of times, and that's my fault. Can you guys let me know? Let's see, changes to the day. So let me know, some of these are probably wrong, so just let me know what's wrong. Jack, I've got you down for 1:30.
Yes.
Colleen, I've got you down for 2.
Yep.
Hudson for 3.
Yep. Sounds good.
Jim for 4.
Yeah.
And Sam for 4:30.
Yes.
Okay. All right. Thanks, everybody. We'll see you this afternoon.
Sounds good.
Okay,
All right. Bye.